Hey everybody, this is Mr. Charnitsky, and this is Unit 4, Lesson 4, Pyramids and Cones. And just like last time, we are going to focus on the surface area and volume, or calculating the surface area and volume of pyramids and cones. We'll start with pyramids, and we'll start with surface area. So here we have the formula for surface area of a pyramid. 1 half P times L plus capital B. And we can tell you what each of these are. So actually a couple corrections here, or specifications. Perimeter of the pyramid, we mean the perimeter of the base of the pyramid. And height of each triangular face, this is also something we will call slant height. Okay. And capital B is area base, that's the same as before. All right, let's talk about why this formula works and where all the parts come from. So just like a prism, we identify pyramids by their bases. So down here we have our square base. So this is known as a square pyramid. And then we have four lateral triangles wrapped around. That's basically every single pyramid. No matter what the shape of your base is, you have your base shape, and then you'll have triangles, equal shaped triangles wrapped around to form your pyramid. So, I guess I shouldn't say equal, I guess a rectangular prism, they would be slightly different, but essentially you're going to have triangles that fold up. So if we were to unwrap this, we would find here's our base, and then around each base we're going to have a triangle. That folds up. Okay. So here's our green base. And then we have four of these. Can't quite get it to do the whole thing, but four of these triangles wrapped around. So essentially, what we're going to do is we are going to find the area of a triangle, but then instead of just doing one triangle, we're going to find all areas at once by essentially using the perimeter around our square here, or whatever shape our base is, to find the, as our base of our triangle. Okay? So if you think about the area of a triangle, it's 1 half base times height, it's lowercase base, lowercase b. Well, the 1 half part that's where this 1 half comes from. Okay. And instead of doing, we could find the area of, just one base here and find one height here and then do that 4 times. But if instead we just use all 4 bases, or however many triangles we have, if we instead find the perimeter of the base and then multiply it times the height, we're going to get all 4 triangles all at once. So that's what we're doing with the perimeter of the base there. And then the height of our pyramid, well, that's actually the height of our triangle, I should say. Height of our triangle is actually, if we think about it, is not the same as the height of our pyramid. The height of our lateral triangle kind of slides down the side of the pyramid, and we call this a slant height. Okay. We'll talk about the actual height of a pyramid when we calculate volume. it's different. It goes straight down the middle of our pyramid. The slant height just goes right down the side of a pyramid as if you're sliding down the side. Okay? So that's where this L comes from. So all this part of our formula here is calculating the lateral area all at once, and then we just have one base here calculating that sums up the bottom base. Okay, so that's where all the parts come from. Let's actually go ahead and calculate our surface area of our pyramid. So we're going to have surface area equal to 1/2. Well, actually, before we get into that, let's work. My eraser's not working. Okay. So let's actually find the parts we need. So area of the base, well, it's just a square, and it's 6 by 6, so that's going to be 6 times 6, or 6 squared, which is going to equal 36. The perimeter of the base is 6. Well, all 4 sides is 6, so 6 plus 6 plus 6 plus 6, or 4 times 6, so that's going to equal 24. And then the slant height is given to us, that's just 12. So now we got all the parts. So the first part, or sorry, for our surface area, we're going to do S equals to 1/2. Perimeter base is 24 times 12 plus our base, which is 36. Okay. A little math on this. So 1/2 of 24 is 12. So we'll have 12 times 12 plus 36. So 12 times 12 is 144. Plus 36 equals 180. And our units would be centimeters squared. Okay. All right. So there's a surface area for our pyramid. I was going to do this this triangular pyramid to illustrate volume, but it's very complicated, and I don't want to get too down the rabbit hole, simply because they don't give us a lot of things, and we'd have to do a lot of side calculations to work this problem. So we're actually going to use the volume formula on this pyramid here, and our volume formula is 1/3 B times H, so it's almost the exact same thing as our prism formula for volume. It's in fact 1/3 of it. So in other words, you could fit 3 pyramids inside a cylinder, or sorry, inside of a prism of the same height and the same base. So in other words, if I had a prism that had a 6 by 6 base and had a height, well, I'm going to talk about height here in the same, but it's the same height, I could fit 3 of these pyramids inside of it. Alright, well, let's calculate the volume of this guy. So volume equals B times H. Well, we already have the area of our base, so that's good. But now we need to find our height. And our height is actually different from our slant height. Our actual height, like I said, is if you were to fall straight down the middle of the pyramid. Okay. The nice thing about this, though, if you're not given your actual height, you're given the slant height. We can actually still calculate this because this actually forms a right triangle here. And so we can do Pythagorean theorem to find the rest. Now, all the way across our base is 6, so that means that this half part is 3. So we got 2 parts of a right triangle, so now we can use Pythagorean theorem to find the actual height here. So Pythagorean theorem, c squared equals a squared plus b squared. We already know c squared is 12, so that's going to be 12 squared. A squared is going to be 3 squared, and then we're going to try and find b squared. That's 144 equal to 9 plus b squared. If we subtract 9 from 144, we get 135. Let's go to b squared, so then we square root 135, and b is approximately equal to 135, square root 135, 11.6. So that's our height of our pyramid, 11.6. So now we've got all the parts. So volume is going to be equal to the area of the base, which is 36. I'm going to go ahead and color code this. 36 times our height, which was 11.6. Use your calculator. 36 times 11.6, which equals 417.6. And our units would be centimeters cubed, or cubic centimeters this time. Okay. So that's surface area and volume of pyramids. Let's look at surface area and volume of cones. A cone, if we were to unwrap it, would have a circular base like this, and then has this kind of weird wedge shape like that attached. And that's actually the net of a cone. So the base of our cone is a circle, which is the pi r squared part, and the pi r L part, which I want to explain. I'm not going to be able to get into details of why that's the case. Getting into some difficult math here, but that is this portion, the pi r L. Okay, so you only need 2 things. You need your radius, which in this case equals 5, and you need your slant height, which is 13. And again, be careful of the difference between slant height and actual height. So slant height is going down the side of our cone. Height with an H would be going down the middle. Okay, let's calculate our surface area. So surface area, surface area is going to be equal to pi times 5 times 13 plus pi times 5 squared. Okay, so 5 times 13, 65, so we got 65 pi here. 5 squared is 25, so we got another 25 pi there. So our exact answer is going to be 65 pi plus 25 pi, which is going to equal 90 pi, which is approximately 282.7 meters squared. All right, that's surface area. Volume, again, very similar to the area of a, to the volume of a prism. It's of a cylinder. It's 1/3 of it, in fact. So a cylinder is pi r squared h. A cone is 1/3 pi r squared h. Okay. All right. So again, we just need radius, which is 5.7. Our height is 12, not 13.3. We want height, which is straight down the middle of our cone, not the slant height. So go ahead and plug these in. So volume is going to equal 1/3 pi, pi times 5.7 squared times 12. Well, 5.7 squared is equal to 32.49 times 12 gives us 389.88. And if I was to divide that by 3, gives us 129.96 pi for our answer, exact answer. So I'll go ahead and multiply that times pi. So we get 408.3 approximately. And that would be cubic centimeters. Okay, and that's how we calculate volume outcome. That's the end of this video.